All right. Hey, everybody. How's it going? I hope you've had a great week so far. My name is Mohi Zara. I'm an AWS serverless developer advocate, which means I make content for you guys, try to find out what you're looking for out of AWS and all of our services and how serverless can help build powerful applications. Today, I wanted to talk about using CircuitPython with AWS serverless. So CircuitPython is a variant of Python, the programming language that works on microcontrollers. And AWS serverless, for those who might not be familiar, is a way to build a series of technologies to build cloud applications without having to manage servers. So the core of that is something called AWS Lambda, which is basically these decoupled computes. It's a function you can run in the cloud in different languages, Node.js, Ruby, Perl, Python. And so we're going to be using Python today. So we can do Python in the cloud and Python on our device, which will allow us to make a device like this. This is a Martian weather display. And so, second. It's using the Adafruit PyPortal. So this is the device outside the case. So the one I have is in a nice orange 3D printed case, but it's got some awesome peripherals on it. So it's got a built-in speaker and SD card slot. It's got Wi-Fi, Bluetooth, an LED. It's got a touch screen, as well as ports to plug in Grove sensors. So it's a really powerful device, all ready to go. And we're going to build this. So this display here, what it's doing is grabbing the latest weather data from Mars using the InSight Mars lander, as well as the latest rover images from the Curiosity Mars rover, and then displays them on here. So switch here. So this is the general overview of the Adafruit PyPortal. They created this device to make it simple to create a sort of IoT dashboard that would be easy to program. As built-in libraries for calling different REST APIs and pulling down images. For the purpose of this, I went and wrote a bit of this outside of the PyPortal library. Again, you see it's quite small, pretty versatile. So last week or 2 weeks ago, I published this blog post on how to build this serverless Martian weather display. You can find it on the AWS Compute blog, aws.amazon.com/blog/compute. And it'll walk through everything that I'm about to walk through. And this is the general overview of the application that we're going to deploy. So this serverless application consists of a Lambda function, which talks to the NASA APIs. So API.nasa.gov has a bunch of free open data APIs for a number of different space-related data sources. So we're using the InSight Weather Service API, which gives us a number of different things, but we're just going to grab the average temperature, the average pressure, the wind speed, and the Martian sol, so the solar day on Mars. Then we're also calling the Mars rover's Photos API. And this gives us a bunch of images for a specific Earth day. And our function will go through those, pick a random image, resize it, and then package that with the data from the InSight lander, and then return that as an object to the JSON object to the device with all that information. And when it resizes that image, it also uploads it to S3. The reason we're doing this in a Lambda function, right? So you might be wondering, why is this happening on a on a cloud function versus just running it on the device because it's running CircuitPython. Well, it's still a limited device. So it needs to resize an image, you need certain Python libraries. And you're also parsing through a lot of different images and different data sources. So doing that, well, you could sort of do that on the device itself. It makes more sense to do it in the cloud where you're reducing the load on the device. And if you need to change something like, say, you're using a different API, you can do or you're using a different API to get the images, you can change that in the Lambda function. And all the device needs to care about is how to call that Lambda function, and it's expecting a certain structure of data. So it doesn't care how you get it or how you do it, as long as it's happening. And you can also obfuscate your credentials. So in this case, our serverless application will have credentials stored on it. In this case, the NASA API key. This is just show in principle how you would build something like this. You would, if you were creating a device that needed some data, you would not want that device to have everything it needs to know to do it because that device can be accessed by someone, right? So this adds a sort of layer of security. Let's start out by, first thing we want to do is we're going to deploy the application. So let's see. So I built this application using the SAM CLI. So SAM stands for Serverless Application Model. Let me bring this text larger. And we'll remove this banner. Is that text readable to y'all? All right. So in here we have the source app. So the structure of this application, right? The way I built it here in SAM CLI and the VS Code using the AWS VS Code toolkit is I have a source directory with our application for the Lambda function, and a core of a Lambda function is really it has this this handler function. So the idea is this Lambda function is invoked in some way from some event source. In this case, our event source is API Gateway, which is Amazon API Gateway, which is a service that lets you create REST APIs. And you can set a Lambda function to be what the REST API calls. And anything that comes in from an API Gateway request gets passed to this Lambda handler, comes back through as an event. In this case, we're not passing any data to it. We're doing that all statically here. And this function is calling, first thing it's doing is it's getting the URL for the rover image. So it calls this fetch rover image function, which we have over here. And what that does is it checks. So one of the things to note is, I said earlier, like we're getting the most recent rover images. Those images aren't updated daily. Again, Mars is very far. And so getting data from Mars can take some time. So often the latest pictures are from the day before, sometimes a couple days before. So this is just going through saying, hey, are we getting any images yet? So once there is length of photos returned by this get rover photos by day function, which takes our day offset and then just makes a call to that NASA API, comes back with an object of photos. Check, do we actually have, because if there's no photos for that day, it just returns an empty array. So we check, okay, do we have photos? Cool, let's grab a random image from that array of photos, grab its URL, pass it into this function, the image data function, which then will actually pull down the image itself because the API returns URLs, fetches that image, and then returns that image body to this resize image function, which will use a couple different libraries like bytes.io to get the actual bytes of the image, put it into a buffer, and then we use the PyImage library to convert it to a bitmap format. We'll first resize it and then convert it to this a bitmap format, and then with 16 colors, because our device is limited, it can only do so much. And then we upload that to a S3 bucket, and then grab the URL for that, return it back out, and then we grab the Mars Insight weather data using another endpoint, and we pull out just what we need. So we're calling the Insight API and creating this object with the data that we want. And then finally, we return that. So this return through API Gateway will return this response to the device when the PyPortal when it makes that request. So it makes a request to API Gateway. API Gateway invokes this Lambda handler. It does all this magic and then returns a JSON body with our image URL and the Insight weather data. And how this application is deployed is all defined in the SAM template. Right? So we've got all this magic going on here, where we are providing the parameter of our NASA API key. We are creating the serverless function and giving it, requiring it to have auth. So that this will show you once we deploy it, that it creates an API key for us for the Lambda function. All right, so actually, yeah, this creates the API, and this creates the function, and we pass it the variable of a bucket that this app is going to create, and the NASA API key, give it the permissions it needs, set it up to have an API REST endpoint. And I'll go a little bit deeper after we deploy this, and then returns back all the information necessary once deployed. So I can do this from the CLI from right here in VS Code. I could deploy the app, but we're going to use the serverless application repository. So the AWS serverless application repository is basically a collection of curated and community contributed serverless applications defined using templates like the one I just showed. So I'm already logged in, I believe, to the AWS console. So then you'll need an AWS account to do this. And all of this can be done within the free tier. So from that blog, click that link. It takes us to the serverless application repository application for the app that we created. So in here, I'm just going to go to application settings and give this a name. So this would be our Mars display. We need to give it a NASA API key. So go back to api.nasa.gov. And a second here, I'm going to bring myself in. No, right. 1 moment. Okay. Oops, what do we have here? Okay. Technical difficulties, and we're back. So we just generate an API key real quick. So you don't need to give this much information other than your email and your name. Click sign up, and it generates a key for you. So grab that API key and drop it in here. So that's all you need to add to create the app. So we'll deploy it. So again, if you have no experience working with AWS, don't want to set up the VS Code and all that, you can just go to this URL from the blog post and just deploy it like that. So now it's deploying that whole application for us. And while it does that, we'll go to the GitHub for this next part. So in the GitHub repository for this application, there is a folder called CircuitPython. In there is all the necessary code that gets put on the PyPortal. So the way you program a PyPortal right, is you plug it in and it shows up as a storage volume. So actually, I'm going to swap SD cards on this. So I'm putting an SD card in it. You just need to put an empty SD card in it that's formatted FAT32 or FAT16. And that's just for storing data that's coming into it. It actually has its own storage built in for putting code on. So that plugs in. And back on my machine, you should see a folder pop up. So this is the core storage of the PyPortal. In here, if you just drop a code.py file at boot, it'll run that code.
There are no other devices to drop in on, and none of your contacts have given you permission to drop in.
Sorry, that's
if you are trying to reach your camera,
computer.
Try saying,
stop. That was my echo. It responds to computer. So again, right, so we're back in here, and so this is, I've already have the repo in here, so let's take a look at the code.py. This is again code that's gonna go on the PyPortal. In here, right, we're doing some stuff, setting up the display, downloading the image, making a request to the Lambda, the API endpoint that goes to the Lambda function. And so this is actually deployed. So back here in the AWS console, once it's deployed, just click on View CloudFormation Stack. And if there's any questions, please feel free to drop them. I can see all the chats from Twitch and Periscope and YouTube. All right, so once we're in that CloudFormation stack, the important bits are in this Outputs tab. And what it gives us is the API URL. So this is the endpoint that calls our Lambda function, and a API key. So if we open that link to the API key in another tab, it takes us to API Gateway, where wants to do. All right. Once this shows, we can click Show API Key, and it gives us that key. So now we have our serverless backend created, right? So that part's now it's time to set up the device. In the blog post, there are instructions that link to also the Adafruit instructions for setting up a PyPortal if you have a new one. The main things to do are to update the bootloader. So this is the bit of firmware that goes on the device that tells it, basically, it gives it the whole CircuitPython runtime. That's done by updating what's called UF2 firmware. So I've already done it on this device, so I'm not going to do it again. But the way you would do it is you double-click this button on the back, and then it shows up as another storage volume where you can then drag this UF2 firmware onto it. It'll update and restart, and now you've got the latest version of CircuitPython. And then you would have to go and download the latest CircuitPython bundle. So Adafruit has done an amazing job. Adafruit has done an amazing job of creating amazing CircuitPython libraries for all the different boards they have that support it. So a lot of the code that you could run on this would run on, say, a PyPortal Pint. On other devices that don't have the display, you could still run parts of this that call the API Gateway endpoint. So similar to updating the UF2 firmware, you just download this Python library bundle and copy it over to the storage volume for the CircuitPython board when it's started up. So again, I've done all that. So all I need to do now is just copy code over to it. But I do need to update a few things. So in the CircuitPython folder, there is a secrets.py file. And in there, we're going to add the Wi-Fi credentials, the API URL, and the API key. So you all now have my Wi-Fi credentials. And we need the API URL. So we go back into CloudFormation, we grab that API URL. Line. And then we grab that API key from API Gateway. Just save that. And we don't need to edit the code. The code is using that secrets.py file to grab everything it needs, right? It needs to connect to Wi-Fi. It needs to know the API URL as well as the API key. One moment. All right. So what we're going to do now is copy this over along with the fonts. So let's just build that in File Explorer. All right. I'm just copy those. Right. Don't need to compile anything. Don't need to do any firmware updating. Just copy code over, right? And so now, if we go to our device, we're going to reload that. So it's starting up. So it'll take a moment, and it's going to make its first request, and then display the info. Let's see, open up. Let's Mupple Editor so we can see what's going on the device. All right. There we go. Cool. So, well, that shows on the camera. All right. It's hard to see. There we go. So, you see, it grabbed the last UTC of the last time it was able to get weather data from the InSight lander. And it looks like this image from the rover is in a odd spot because that's just not the webcam seeing that. It's a very blurry photo from Mars. But sometimes you get like really beautiful photos of just Martian landscapes. And so this will, every couple of minutes, grab the, so actually we set that in the secrets file. We set the interval to 5 minutes. So every 5 minutes, it's going to grab a new photo. So I will show you the serial output for the device here. Let's see. So I'm going to switch back to my screen. So this is a tool called Mupple Editor. This is linked in the blog post. So this is an optional thing you can install. It's a great way to edit and modify code, as well as reading over serial through the CircuitPython REPL what's going on the device. So anytime, in the same way that you would do console.log, it's kind of like that, where anything you print will show up in this. So as I restart that, we should see. All right, I might need to start serial again. Oh, having issues. There we go. So hopefully this will actually show us something. Or maybe not. Must have too many USB devices, so we're not going to see it on there, but you would see that. All right, so let's walk back through what all went into this, right? So starting at code.py. So this is the CircuitPython code. So, I see someone said that they missed most of the video. This, the recording of this will all be available on YouTube and on end on Twitch. So right after the stream ends, so you'll be able to go back and check all of this. So in the CircuitPython code, again, not typical Python, but it's all the same type of syntax, everything you would do, like same as how we did the Lambda function. It's just regular old Python, but with access to I/O. So these are the libraries we're including. Main thing is we're calling the Adafruit ESP32 Wi-Fi library. So the PyPortal is it's a separate chip that uses the ESP32 as a Wi-Fi coprocessor. So you're not actually programming ESP32. This already has firmware on it to handle all the Wi-Fi stuff. And then the main chip, which I'll pull it up in a second, which one that is. I believe it's an Atmel chip, is what we're actually programming. So it's got storage on there that we're putting the code on. And then we include the display IO library, which is a graphics library for the PyPortal. Then we include a font. So PyPortal, the display IO library to do text requires that you use a bitmap font. So they have instructions for converting fonts and all that. So this is just one I happen to use that was decent looking. And we start the Wi-Fi, we create our display groups, and all that fun stuff for displaying the text and the image. But right, the main part to think about is here. So this is the main loop, if you will. So if you're familiar with Arduino, there's a constant loop running. Because it's Python, it's interpreter based, right? Once it gets down to the line, it's done and it'll just like restart. So we create this loop to make sure that we regularly like display and grab images. So it's calling, first thing it's doing is it's getting the data by calling this API endpoint function and passing it from the secrets. So this is passed through as a JSON object from the secrets.py file. Say, give us the Mars API URL, pass it to this function. And in there, we set our API key in our headers. So this is the API key from Amazon API Gateway. Then we make a REST request using the Wi-Fi manager library, say wi-fi.get from the Mars API URL, the API gateway that calls a Lambda function. And one thing to note is on CircuitPython, when making a REST request to an API gateway endpoint, you want to include a timeout of 30 milliseconds, just because with integrations and the way security is set up through SSL on API gateway endpoints, it can take just a smidge longer than the standard 10 millisecond timeout. And then that returns back the response as JSON. So we're taking the response, grabbing the JSON, and then we're just going to return that back out in this function. So now we have the data all in that. So that is that's that JSON object, right? That has bring that back up. So that's the JSON object that has the image URL, and it has all the insight weather data, right? So then we take that image URL from that return JSON, pass it to the download image function, and we give it 5 max retries, just because it's a device and sometimes you can miss a bit. And we're going to get the file. So we use PyPortal to, so the Adafruit PyPortal library has a helper function called wget, which functions just like wget on the Linux terminal, right, or command line. Pass it a URL, and we tell it where to store it and what file name. So this will, under the hood, it opens up the SD card. So it includes all the libraries necessary to access the SD card interface, sets chunk size, brings down that whole image as bitmap, saves it, and lets us know if it errors out. And then now, so far our PyPortal has called the API gateway endpoint, has pulled down is call that Lambda function that pull down all the NASA API data, as well as the resized an image, converted to bitmap, put it in an S3 bucket, and provided that URL back. It's then downloaded that image and saved it to the SD card on the device. So now it has everything it needs to just go ahead and show the display. So the show display function, we pass it the insight data. And this goes through, opens the SD card file, grabs that bitmap file, stores it on disk, so like it's on memory, and then passes it to display IO to basically set it as an image. So this is how it would show it. It adds it to a tile grid, and then adds it to that background group. So this is some more nitty-gritty stuff you can look into, the display IO library. Then it calls another function to set all the insight data, which basically just calls another function I've made called set text, where you pass it a display group, the text you want to display, and the data value and the position where to display it. So if you look at set text, all that's really doing is concatenating that string you passed it with the JSON or the value you passed it as well, creates a label, which is another display object. Tells it it has max glyphs of 200. That's just how many characters it has. And then tells it where to position that based on what you passed in, and then appends it to the group that you passed in. And then finally, after it does all that for every bit of text that we have here, it then finally shows the display by showing the main group that everything is under, the main display group. And then boom, that's how it displays the image and the Mars data. So at the end of the day, when you look at the process of setting this up, right? So if you were making a project and you wanted to share it, you build that serverless application, you would then upload that or add that to the serverless application repository, share that link out. So now someone can easily set up their backend, and then you just give them a bit of Python, CircuitPython code, and tell them put that on PyPortal. Now anybody can have an IoT device that displays data. So with that, I'll open for questions. So if anybody has any questions, please feel free to drop them. Otherwise, we'll close off with that. Again, my name is, doesn't look like we're getting questions. So my name is Moeeb Zara. You can find me on Twitter, Instagram, all that fun stuff through @VirtualVox. Feel free to reach out to me. My DMs are always open. If you ever have a project you're working on, something you're interested in, I'd be happy to help out. Any insight I can share and any insight I can get from you guys. I'm always trying to build something. My next project is using MicroPython, which is what CircuitPython's for, from using this M5 stack module. Similarly, runs Python code, has Wi-Fi, Bluetooth, SD cards, speaker, and mic. So look out for that content. Thanks for viewing, and have a good rest of your week. I hope you get a chance to hack on this. Cheers.